Hello world, Nick here, and this is video number 4 in my Java programming tutorial. And today we are going to go over the data types in Java. So I'm in the same adder class that we used last video. We're not going to be making an adder, but we're not actually going to really be making anything in this video. I'm just going to be showing you some of the things we're going to need to use in order to make things. So these primitive data types are the ways that we're going to store data. So we're going to start with one that we've already seen before, and that's an int. So an int, it stores an integer, and it is 32 bits in size. So what that means is that any int that you see is encoded as in our computer as 32 zeros and ones. So we've already seen an example of this. It's any number that is an integer and is within a certain range, but don't have to worry about that too much yet. So we have int x equals 8, and then we've already seen this before, but if we system.out.println x, it prints 8. But we already knew that. So let's get to a data type that we haven't seen yet. Now we're going to talk about something called a Boolean. So a Boolean is going to be, well, I'm going to show you what it is and then you tell me how many bits you think it is. So Boolean, an example would be something like coin lands heads equals true. So a Boolean, as the name implies, holds either a true or a false value. So an example would be something like if we have a coin flipping program, we could have a Boolean called coin lands heads, and if that's true, we set that to true if the coin lands on heads, and then we set that to false otherwise, and then we can print out its value, and it just prints out the word either true or false. So one thing to kind of remember is that Boolean doesn't actually store the word true or the word false. It just stores either a 0 or a 1 corresponding to whether it's true or false. So if it stores just a single 0 or a single 1, and that tells us whether it's true or false, then you could probably guess it uses up 1 bit. Now that's not exactly true. All data types are kind of dependent on the JVM, but that's kind of beyond the scope of this lesson. But as far as the data that is actually used to store that specific variable, it's just going to be 1 bit. So that's the smallest we can get. So our next data type we're going to look at is, let's say we want to store an integer, and x equals 4, but we know that the number is never going to get very big. We know it's never going to get bigger than 10, let's say. Then what we can do is we can call it a byte. So you probably already know a byte is 8 bits. So that's just any number that's going to fall between, I think the range is 1, yeah, so it's any number from negative 128. So if we put negative 129, it's going to give us an error. So a byte is any number from negative 128 up to 127. So that's a range of numbers you can store using 8 bits, and if you know that your number is never going to get bigger than 127 or smaller than negative 128, a byte uses less space than an int, so in general it's better to use that, but the space difference isn't too huge unless you're storing a giant list of numbers. So you could use an int, just make it easier to read, but technically you should use a byte in that case. And it works the same way if we print that the value of that byte, it'll give us 127. So this brings us to kind of an interesting mechanic in Java, which is something called integer overflow. So what happens if here we're at 127, it's the highest value we can store. What happens if we try to add 1 to it? So we take x and we set it equal to itself plus 1. Well, it's not going to let us do that because you cannot convert from an int to byte. But if it's just x, it's fine. So the reason that it gives us that problem is because x plus 1 is not in the range of a byte. That's 127 plus 1 is 128. So because that's not in the range of our data type, Java gives us an error, which is kind of nice. In a lot of languages, a lot of programming languages, they would not give us an error, and then it would just let that happen, then it would act all wacky and weird. So it's nice that Java kind of handles that for us. So that's our byte. Next is a short, which is 16 bits. So a short is the same sort of thing. It's an integer, and it's twice the size of a byte, but half the size of an int. So a short can store any number. I don't know the exact range, but it's somewhere in the range of around 50,000, I believe. Right. So let's see. So if we put short x equals 50,000, do we get an error? Does that not work? Yes, that's too big. 5,000, that works. So I'm not going to figure out exactly where the cutoff is. You can find that online. But a short is kind of right between a byte and an int. But what if we need something bigger than an int? Because even an int has a maximum. It's a pretty high maximum, but there is a point where we can't store the number in an int anymore. There we go. So it's a pretty high number. But sometimes we want to store a number bigger than this. We're going to use a data type called long, and that is going to be 64 bits. So a long has double the capacity of an int, and longs can be gigantic numbers. You can look up the range on your own. I don't know it off the top of my head, but basically any huge number could fit. Let's give this variable name. Any integer you would ever have to use can fit into a long, is the general rule. Somewhere from like negative something billion to positive something billion. So pretty much any number you'd ever need fits into a long. So now we are going to move on to, what about if we wanted to store, instead of an integer, we want to store something that, a decimal number. Well, Java has you covered. There's a type called a float, which can store a decimal number, and that's 32 bits. But the one we're going to use pretty much always is a type called double, which is 64 bits, because they're both the same thing, except that a double has twice the precision, or it has twice the size as more than twice the precision. So it's pretty cool the way that they squeeze decimal numbers like this into 64 bits, because a bit is just a 0 or 1. So they can fit a huge amount of decimal numbers into just a string of 64 zeros or ones. But that doesn't really matter. So something to look up if you ever feel like figuring that out. But anyway, I'm getting distracted. So a double is something like this. It's any decimal number. It's 4.5, 0.25, 300. I'm not going to sit here and give you all the possible decimal numbers. You know what those look like. But there's no real limit on it. You can put, there is a limit, but it's kind of not intuitive as to how it works, because you have limits as to precision and also as to magnitude, and the way it works is really tricky. But in general, any decimal number you want to store, just put it in a double and you're good. So now we have 1, 2, 3, 4, 5, 6, 7 data types, means we're missing 1, because there are 8 primitive data types in Java. The last one is something called a character. So that's char for short, and that is 8 bits. So an example of a character would be, something like anything on your keyboard counts as a character. H. Now, for characters, we want to put the character inside of single quotes. So the reason we do that is because we want to differentiate it from, if we didn't put it in single quotes, then Java is going to look for like some other variable called h, which isn't what we're doing here. We want to set it to the literal character h. So that's what the single quotes are for. We don't use double quotes because that's a string if we use double quotes, and yeah, you might notice we didn't put string here, although we used that before, and that's because string isn't exactly a primitive data type. We'll go into string in the next video because that's a pretty important case, but it's not a primitive data type. So we're going to kind of put that on the back burner for this video, and we can store any character on your keyboard for the most part inside of this. So let's go ahead, and if we print out letter H, what we'll get is, you probably guessed, the capital letter H, because that's what letter H is equal to. So this is a character, and this is our final data type. So these are the 8 primitive data types in Java. You're going to be using these a lot, like for pretty much everything. And we'll go into string, which is a pretty interesting case. There's a lot you can do with it because it's not exactly a primitive data type. But these are the 8. You're going to, don't really worry about how much space they use. That's not something for you to worry about for a while. You're not going to be optimizing programs for minimum space usage anytime soon. It's kind of, you'll never have to know how much space they use unless you're like interviewing for a computer science job and your interviewer decides it's important to know exactly how many bits a float uses. But these are the 8 data types. You can like add an int to a short. You can add a float to a double. They're all kind of loose in the way that they work, but sometimes in order to convert one to the other, you'll have to do something called casting, but I will go into that 2 videos from now. That's how I'm going to keep you interested. I'll leave you on that cliffhanger. So we'll get into that in 2 videos. Next video we're going to talk about strings and how they work. And that's it for now. See you all later.